Morning to everyone. Last class we have seen about mathematical modeling of op-amp based electronic circuits and why do we need a block diagram reduction technique. That is how we can represent a control system in block diagrammatically. That too for a large control system, how we can represent it and what are the methods we'll be using for determining the transfer function by using block diagram reduction technique. And we saw the major components of block diagram, that is block, summing point and branch point. Today we are going to see about block diagram reduction technique rules. So there are several rules which are to be followed in block diagram reduction technique for obtaining the transfer function. Okay, you'll see the rule one by one. The first rule is, for example, in our block diagram representing a control system includes a block like this, two blocks in cascade. Here we have taken a block as G1 and another block as G2. Like this we are having two blocks G1 and G2 in series. Then what can we do? We shall see. See here in this figure G1 is there and we are giving A as a input to this block G1 and the obtained output from this block G1 is AG1, and then to the block G2 we are going to give the input AG1. Okay, and finally we'll be obtaining the input, that is output AG1 G2. Okay, so when an input is given to a block, the output will be the input into the block. That is, when we are giving A to the block G1, the output is A into G1, because this G1 is nothing but a mathematical operation or a function we can say. So only we are getting A into G1 while A is given as input to G1. And again this input AG1 is given to the block G2 and we will be getting AG1 into G2. Okay. Suppose if you are having two blocks like this in series, then we can reduce the block diagram like this. That is G1 and G2 can be represented in a single block and the input given to this block is A. See the output here obtained is A into G1 and G2. So in this both the case, the output is same A into G1 and G2, but here we are having the two blocks G1 and G2 separately, that is in cascaded form. Here we have combined this G1 and G2. Likewise, we can reduce the two blocks G1 and G2 into a single block G1 G2 using this block diagram reduction technique, rule number 1. Okay. Next we shall see rule number 2. So here in our block diagram of a control system, if we are having two blocks G1 and G2, it may be G1 and G2 or some other name. Okay. And a common input, say A, is given to the two blocks G1 and G2. So what will be the output obtained from this block G1 will be AG1. The output obtained from this block G2 is AG2, because here the common input A is given to both the box G1 and G2. See here, after this the output from the G1 block and output from the G2 block is given to a summing point. This circle with some into mark is known as a summing point. See, this AG1 is fed to the summing point with positive sign and AG2 is fed to this input with positive sign. So our output will be AG1 plus AG2, because both are positive sign. So we are having AG1 plus AG2. Suppose in this case, if we have, while this AG2 is fed into the summing point with the negative sign, means our output will be here AG1 minus AG2 if AG2 is fed with negative sign. Okay, if AG1 is fed with negative sign means our output will be minus AG1 plus AG2. Okay, depending upon the sign given to this summing point, we'll be obtaining the output from this type of blocks. So here in this output, we are having plus and plus fed to the summing point. So AG1 plus AG2 here, we can take A common to both the terms. Likewise, we'll be obtaining A into G1 plus G2. Okay. Then how we can reduce this block, we shall see. So here we can reduce the block as a single block G1 plus G2. See here, G1 and G2 is summed up or added using the summing point. So those operation can be done in a single block G1 plus G2. See here the output will be same. See here also we are giving the same input A and the output is A into G1 plus G2. See here in both the case the output is A into G1 plus G2. Thus if you are having two blocks in parallel with the summing point, then we can convert it into the summation of the two blocks in a single block. Okay, like this we can combine a parallel block. If a block is in series means it will be multiplied like this. If a block is in parallel with the summing point, it will be added with the corresponding sign. Okay. Next we shall see rule number 3. See here. First we shall see with the help of this diagram. See here we are having a block G. An input A is given to this block G. Here we are having a branch point. So this is what a branch point is. So through this branch point we are obtaining this input A and giving to some other block which may be available here. Okay. So through this branch point we are obtaining this same input A and we may give it to some other blocks. But our output here will be A into G, and through this branch point what will be obtaining? A. So while reducing the block diagram, we may have some situation while moving the branch point ahead of the block. If we have so, then if we want to move this branch point ahead of this block G means, see here we obtain only A. If we are keeping this branch point ahead of G means we will be getting AG from this point. See here, if we move this branch point ahead of this block G, we will be getting AG from this point because A input is given here, and after this block what the output will be getting? A into G. So our desired input from this branch point is A, but here we got AG. So to convert this AG into A, we have to divide it. We have to divide the signal by G. So only we have included a block 1 by G here. So our resultant will be A here. Okay. So these two figure represent the same thing. That is, here we had moved the branch point ahead of the block. If you are going to move the branch point ahead of the block, we have to include a term 1 by G. Okay, here we have moved the branch point ahead of the block G. So we have included the term 1 by G in the branch point to obtain the same signal. Here the signal in the branch point is A. Here also the signal in the branch point is A. Okay. This is rule number 3. Next we shall see rule number 4. So here this rule number 4 also we are having a block G, and here the input is given as A and the output obtained will be AG. Suppose here we are having a branch point. So here the branch point represents the signal AG. Okay. This branch point signal AG may be given to some other block available. So if you want to move this branch point before this block G, then what we have to do? We shall see. In some cases, we may need to move the branch point before the block to reduce the block diagram and all. For that, what are the steps we need to follow? We shall see. So, here the obtain signal from the obtained signal from this branch point is AG. If you move this branch point before the block G, okay. If you move this branch point before the block G, we'll be getting only A. So, to obtain A into G, we need to insert a block G here. Okay, see here how we have inserted G. Because here we have moved this branch point before the block G. So, we have to include the block G in the branch point to get the same signal AG. See here, we are getting the same signal AG, AG. Okay, this is rule number 4. Next, we shall see the rule number 5. Here, this we are having two signals A and B. Okay, so this two input A and B is fed to a summing point, the positive sign. So it is A plus B is the output obtained from this summing point, and this A plus B is given to the block G. So after this block we will be having A plus B into G. Okay. So in some cases we may need to move the summing point ahead of this block G. So if we want to do so, how we can do, we shall see. Here, if we want to move it ahead of G means, we have to include this G in both the input A and B. Okay. So here, its equivalent is given. See here, while obtaining the input A and input B, we have included the block G. Here also we have included G. So only our input to the summing point will be AG plus AG. So AG plus BG is equal to A plus B into G. So see here, here also we have obtained the output A plus BG. Here also the output is A plus B into G. Okay. So for moving the summing point ahead of a block, we have to include that block G to the input of the summing point. Okay. This is rule number 5. Next we shall see rule number 6. See, here in this rule, we are having two inputs A and B. This input A is given to the block G. After that only it is summed up using the summing point. Here we are having B also fed to the summing point, both in positive sign. So our resultant will be AG plus B. Okay. So in some cases we may move this summing point before this block G. So if you are doing so means, what we shall do, we shall see. So while moving this summing point before G, then this G will be included in both the inputs A and B. But here this G is included only in A, not in B. So what we have to do? We have to include a term 1 by G in the summing point. Okay. So here the input A is given directly to the summing point. This input B only, we no need to have the block G. So we have included the block 1 by G in the path of the input B. So the obtained result from this block 1 by G will be B by G. So here what we are summing up, A plus B by G. So the obtained output from the summing point is A plus B by G. And this A plus B by G is given to this block G. So the obtained output will be AG plus B. See here, here also we obtain the output AG plus B. Here also we obtain the output AG plus B. So to move the summing point before a block, what we have to do? We have to include the term 1 by G for the input which need not have the block G multiplied. Okay, clear? So likewise, we have seen here this rule number 6. Next we shall see rule number 7. So in this figure, here you can see two summing point. So in the first summing point, the input is A and the another input is B. Both are in plus sign. So in the output of the first summing point, we are having A plus B. This term A plus B is fed to the second summing point. The second summing point, we are having another input C. It is fed to the summing point with the negative sign. So, we can have A plus B minus C. Minus C, why means? Because here we are having minus. So, the output is A plus B minus C. So, we can interchange the summing point. So, what are the changes to be done? If you are interchanging the summing point. So, here, we are interchanging the summing point means the second summing point, the input C is added. So, this input C should be added in the first summing point. So, see here, after interchanging, it becomes to the first summing point, this A and this C is fed to the summing point with a negative sign. So the output from this first summing point is A minus C. And this output A minus C is fed to the second summing point. The second summing point, we are having the input B. So A minus B plus A minus C plus B is equal to A plus B minus C. So see here, we have interchanged the summing point. That is, along with that plus minus symbol, we have interchanged this C also to the first summing point. And the second summing point, this plus symbol, we have included this B. This is the vice versa of this first one. Okay. Likewise, while interchanging the summing point, we have to interchange the input given to the summing point as well as what the sign available in the interchanged summing point. If we do so, we will be getting the equivalent result. So, this is rule number 7. Next, we shall see the next rule. See here in this figure, so we are having two summing point. The first summing point, we are having the input A and B is fed to the summing point with positive sign. So the output from the summing point is A plus B. And this A plus B is given to the second summing point with the positive sign. And this input C is fed to the second summing point with a negative sign. So the resultant output will be A plus B minus C. So here we can combine the summing point also. Because as we said in the previous classes, a summing point can have or can add or subtract two or more input. So here we are having three input A, B, C. So these three input A, B, C can be given to the same single summing point. So how we can give? We shall see here. See here, we have drawn a single summing point and this A is fed with the positive sign. See here, it is fed with the positive sign. So here also it is fed with the positive sign. See here, the B is fed with positive sign. So here also B is fed with positive sign. See here, C is fed with negative sign. So here also C is fed with negative sign. So the resultant is A plus B minus C. See here, in both the cases, the output is A plus B minus C. Okay, like this we can combine the summing point. Next we shall see how we can split the summing point. So splitting the summing point is the vice versa of the rule number 8. See here, we are having a single summing point. To the summing point, we are giving A, B, C input, the terminals plus, plus, minus respectively. And we have obtained the output A plus B minus C. So see here we are having two summing point. So how we can split the two summing point? If you see, we can have two input in first summing point and the another input may be added in the second summing point. Likewise, if I have means here in the first summing point, I can have A and B. See here in this combined summing point itself, A and B has positive sign. So the same positive sign is given to A and B. So the output from this first summing point is A plus B. So this output A plus B is given to the second summing point with another input C, and that C input is fed with negative sign. So the obtained output is A plus B minus C. See here we are having A plus B minus C is equivalent to A plus B minus C. So likewise we can split the summing point also. Still we are having two more rules. Before seeing the other two rules, we shall see few topics related to those two rules. Okay. So we see the transfer function of a open loop system. So here a open loop system is given. So how we are saying it is an open loop system? Because the output is not fed back to the input. So it is an open loop system only. Here in this system, R of S is the input given and C of S is the output obtained and G of S is the transfer function. Okay. So we can say what is the transfer function for open loop system? G of S is equal to C of S by R of S. That is by the definition of transfer function. Transfer function is the ratio of Laplace transform of output of the system to the Laplace transform of input of the system. Thus, we can obtain transfer function of a open loop system like this. Next, we shall see the transfer function of a closed loop system. So, in closed loop system, we are having two types. The first type is negative feedback system. The second one is positive feedback system. Okay. First, we shall see the negative feedback system. So, here in this slide, we are having a negative feedback system. See here, it's a negative feedback system. See here, the input is R of S. This is given to the summing point. And next to the summing point, we are having a block G of S and the output is C of S. The C of S is given or it is fed back to the input through the transfer to a function H of S to this summing point and it is fed through the input side. So here in this negative feedback system we are having a block in forward path and another block in feedback path. So G of S is available in forward path and H of S is available in feedback path. So here in the feedback path what we are having? We are having H of S block which is given to the summing point with negative sign. So only we are saying this as negative feedback system. See here the input is fed to the summing point with a positive sign, but this feedback function H of S is fed to the summing point with a negative sign. So only it is known as negative feedback system. So now we shall see how to determine the transfer function of this closed loop system, particularly the negative feedback system. So here if you see means the feedback signal B of S. Here, what is the signal fed back from the output to the summing point is B of S. So we can say this B of S is equal to output into feedback path gain. That is, here we got the output C of S and it is multiplied with the feedback path gain H of S. This is known as feedback path gain. So in the feedback path, we are giving a function and this function is known as feedback path gain. Okay. So this H of S is nothing but feedback path gain. So we can obtain B of S as C of S into H of S. Okay. Like this we have given this equation 1, which is B of S is equal to C of S into H of S. Next we shall see the error signal. This E of S is the error signal. We'll be saying it as error signal. It is provided to this closed loop system for providing accuracy in the result. So only this is known as error signal. So here this error signal E of S is the output of this summing point. So E of S can be said as R of S minus B of S, or E of S is equal to input signal minus feedback signal. Okay. So E of S is equal to R of S minus B of S. Then substituting this E of S is equal to R of S minus B of S. Here we can substitute B of S from the equation 1. See, in this equation 1, we are having B of S. So this value of B of S is substituted in the equation of error signal E of S. Thus, we can obtain this equation 2. So what is the value of B of S? B of S is equal to C of S into H of S. Thus, by substituting, we obtain this equation 2. And next, we can determine the output signal. See here, in this negative feedback loop structure, we can see the C of S is the output signal. So what is this value of the C of S? Here we are having E of S, this is multiply. This is given to this block G of S and we have obtained in the output. So C of S is equal to E of S into G of S. That is error signal into forward path gain. This G of S, that is the block given in the forward path, is known as forward path gain. The block given in the feedback path is known as feedback path gain. So this G of S is the forward path gain because this block G of S is given in the forward path. So thus we can obtain the output signal as C of S is equal to E of S into G of S. See here we have written C of this equation 3, C of S is equal to E of S into G of S. Then here this equation 3 we can substitute the value of E of S. This is obtained from equation 2. Okay, while substituting so we will be obtaining our equation like this. So here C of S is equal to R of S into G of S. This R of S, this value of E of S substituted from this equation 2, that is R of S minus C of S H of S with G of S. So this equation becomes like this. And next, to obtain the transfer function, we need the ratio of output by input. So the C of S is the output. So we can bring C of S to left hand side. We can take this R of S, which is the input, to the right hand side. Then here I have taken C of S common. After that, to obtain the transfer function, what we shall do? We need to divide the output by input. So C of S by R of S can be written as G of S in this side and we are bringing is 1 plus g of s h of s to the denominator in the right hand side. So thus we have obtained the transfer function of a negative feedback system. Okay. So this is the value of the transfer function of a negative feedback control system if g of s is the forward path gain. Forward path gain means this block G of S is the block which was available in the forward path, and H of S is the feedback path gain. That is, this block H of S is available in the feedback path. Okay. So we can simplify this negative feedback system and we can write it as like this. The same input R of S is given, the output C of S is obtained here, the transfer function obtained. Okay. See here, we have obtained the transfer function in words, that is forward path gain divided by 1 plus forward path gain into feedback path gain. Here, from here we can also obtain the, see from this equation, transfer function is equal to output by input. We can obtain the output also. We are obtaining like this. Can say C of S is equal to closed loop transfer function T of S into input R of S. Okay. Thus we can obtain the transfer function as well as the output. If we want, we can get from the closed loop control system. Here we have seen the closed loop control system of negative feedback system we have seen. Next, the same way we can also derive the transfer function of positive feedback system. See here, we have shown the block diagram of positive feedback system. So here also we are having a block in the forward path and another block in the feedback path. And this G of S is the forward path gain and H of S is the feedback path gain. And here you can see this H of S is fed with positive sign to the summing point. So this is the difference of positive feedback system from negative feedback system. So here in positive feedback system, the output C of S is fed through this block H of S with a positive sign. Okay. So by applying the previous procedure, if we obtain the transfer function means we'll be getting the value of transfer function as this. This T of S is equal to C of S by R of S. Here we'll be getting G of S divided by 1 minus G of S H of S. Here only in negative feedback system we had the transfer function, the denominator we had 1 plus G of S H of S. In positive feedback system, the denominator we are having 1 plus minus G of S H of S. See here, this is the transfer function of negative feedback system. This is G of S by 1 plus G of S H of S. So denominator we are having positive sign. See here, the denominator we are having negative sign. So this is the difference while considering the transfer function. Okay, thus we have seen the procedure for obtaining the transfer function of negative feedback system. The same can be applied to positive feedback system, and if we do so, this is our transfer function. So this we shall see the rule number 10. The rule number 10 is nothing but the elimination of negative feedback loop. See, in the previous case itself, we have seen the negative feedback loop system. See here in the forward path, we are having G, and in the feedback path, we are having H, and the input is R and the output is C means. As in the previous set procedure, we can obtain the transfer function as G by 1 plus GH. So the simplified procedure for this is given here, the same as what we have did in the previous step. So thus we can eliminate a negative feedback system We can write it like this. The same way, we can eliminate the positive feedback loop system. We do so. Here in this positive feedback, this H is fed with positive sign. Negative feedback system, see here, this H is fed with negative sign. That is the difference between positive feedback system and negative feedback system. So, our transfer function becomes G by 1 minus GH. That is the input given is R and the output obtained is C. Okay. The proof is given here. That is similar to the procedure which we have seen in the previous slides. Okay. So in today's class, what are all the topics we have seen? We have seen the rules for block diagram reduction techniques. We have seen some 9 rules in today's class. After this 9 rules, we saw about the transfer function of open loop system and how we can obtain the transfer function of closed loop system. It is divided into two types, negative feedback system and positive feedback system, and how we can obtain it with the derivation we have seen in today's class. And also the rule number 10 and 11 is nothing but eliminating the negative feedback as the same procedure which we have discussed in the previous slide, and the positive feedback loop elimination is also the same procedure as previous slide. Okay, thank you.